Now, I started out this section with a function, y equals f of x, and I calculated its derivative. And I got another function, f prime of x. Well, if differentiation is something I can do to functions, and I have a function, can't I take another derivative? Well, yes, I can. So let's say I have a function f. Let's go ahead and say that it's a differentiable function, so this all makes sense. It'll have a derivative, and I'll call that f prime. Here in this slide, I've dropped the parentheses x. So anytime I'm just talking about that letter f, I just mean the function itself. Well, f prime is also a function. Maybe f prime also has a derivative. So if I want to take another derivative, I can do that, right? I'll take the limit of f prime of x plus h minus f prime of x all on h, and I would get the derivative of f prime. Well, what would I call that? F prime prime? So for notation, we're going to stick another apostrophe up top on my f. We get f double prime, is the way I would say that out loud. In terms of my original function, right, f is the function I started with, f double prime is going to be the second derivative of f, because that's how many times I've calculated derivatives. Now, if you're going to use the Leibniz notation, then I'm starting out with the first derivative of the function, which is my dy on dx, and I'm applying the differential operator a second time. So here is my differentiation operator, d on dx. I'm giving that the function dy on dx. So what do I get? Well, the Leibniz notation says we get d squared y on dx squared. So this might not be the most intuitive thing in the world. We're taking two differentials of the variable y. We're dividing by the differential x squared. Again, that might not be the most intuitive thing. This is part of the reason why we say that dy on dx is just a symbol. It's not actually a fraction. So let's actually calculate something like this. Let's take the function f of x is equal to x cubed minus x. We're going to find its second derivative, f prime of x. So in my first derivative, I'm going to take my limit, and the scratch work is not shown on this slide, but we'll get 3x squared minus 1. The second derivative is the derivative of the first derivative. So we've got to take this 3x squared minus 1 formula, and we'll use that to find the second derivative. So now I'm taking the limit as h goes to 0, f prime of x plus h, all minus f prime of x, that whole mess divided by h. So here I've used the formula for f prime of x. Every time I see an x plus h, I've got 3x plus h squared minus 1. I subtract off 3x squared minus 1. And I'm going to FOIL that out and simplify it, do some cancellation. I get the limit as h goes to 0 of 6x plus 3h. H is going to 0, so I just get 6x. That tells me that my derivative here is f double prime is 6 times x. And here are all of those functions graphed together.